So here's the next problem for the problem of the day, that is a partition equal subset sum. Okay, so what this question is saying that let's just see. Okay, so the question name is partition equal subset sum. Okay, so in this question it's written that we will given an integer array nums, that is here, and we have to return true if the partition the array. Basically, if I just explain you the question, we have to partition this array in two equal subsets. Okay, like and the sum of those subsets should be equal. Okay, so like in this 11 and 1 5 5 5, that is, you can see these are the two subsets. If you sum this, that is 1 plus 5 plus 5, that gives 11, and here also it gives 11. So that's why their sum is equal. Okay, so this is the basically the code, the question. Okay, so in this also you can see you can't basically break this array into two subsets whose sum is equal. Basically, if you see one thing, we can say that if we sum all these numbers, that is, let's just write here. Okay, so if I just write here, okay, so if I just write array, okay, 1 5, what is the array? This. Okay, okay, so this is the array, that is the example array. Okay, 1 5 11 5. Okay, so if you will see that if we add all the numbers in this, okay, 1 plus 5, that is 6, plus 11, that is 17, and 5 22, that will simply equals to 22. Okay, so if we divide this 22 by 2, then it gives 11. Okay, so you need to find two basically sub arrays, or you can say subset that sums equals to 11. Okay, so one thing we got that if whenever the sum, that is, if we take this, okay, this second one, if you will sum it all, basically if you sum all the numbers, that is 3 3 6 and 5 11, that is the sum is odd. So simply you can say whenever the sum is odd, basically the sum of all the integer in the array is odd, it basically simply return false. Okay, okay, simply return false. Okay, and if the sum is even, then you can simply divide by 2 and you can find this number, basically find this target in this subset, basically in this array, basically which subset forms this target. Okay, one more thing I want to basically tell you, you just need not to find the two subsets, basically like 1 5 and 5 and then 11. You just find a single subset that equals to this sum. Okay, if you find this 11, okay, in this array, then you can simply return true, because if the subset contains the half sum, that is, if it contains 11, okay, then obviously by math you can say that remaining elements, if we add remaining element, then it obviously contains this same sum. Okay, because the total sum is the adding both. Okay, the basically half of this. Okay, so if a subset, that is, if I just take the same example, that is 1, okay, 5 11 and 5. Okay, if you find the one subset, that is this. Okay, if you find this, okay, with 11 sum, okay, the target is 11, then you just can return true. Okay, without checking the second subset. Okay, we don't need to find all basically both subset, just return true whenever we find one subset, because obviously this is the half of it. Okay, so remaining subset, remaining basically integer will contain obviously if we add all the remaining integers, then it will simply goes to equals to the same target. Okay, so simply it will be a subset. Okay, so simply you can say we just have to find the one subset that equals to the target, and the target is the total sum by 2. Okay, so basically this is the question. Now the question changes to the a very famous question, that is DP question, that is sum of subset equals to k. Okay, that is the k is the target value. So it's the very famous DP question. Okay, so it's just equals to the same question. Okay, that is this question. Okay, now, okay, so basically target is sum by 2, and simply we have to find a subset that equals to this target, and we have to return true and false. Okay, so simply the same question. So let's just jump on the question. So what we are going to do, we are going to take the, let's just take an array. Okay, so the example, that is this 1 5 11 and this 5. Okay, so simply we have taken this array. So what we are going to do, we are going to start from the last. Okay, so we are going to start from the last. We will create a function that will simply take two things, that is index, okay, and the target. Okay, the target. So simply it will take two things, that is the index and the target. Okay, simply if you just see that how basically this is going to work, let's just see. Okay, it's like if I see that, okay, let's just write it. Okay, so let's just use this. Okay, so f, that's the function index and target. Okay, then we will take these two. Okay, so simply this is going to start from the last. Okay, so simply it will take this. It will have two choices, that it can take it or not take it. Okay, because it is a subset, then we can include it or not include it. Then it will have simply say that two choices, that is simply, okay, here you can say if it has taken it. Okay, if it has taken this 5. Okay, then what will the basically new thing. Okay, so simply if it has taken, then simply index would be what will the index would be simply 1. No, so the index is like here at last, so 0 1 2 3. Okay, so the index is 3. Okay, and if it is taken, the number is 5. Okay, and if it is not taken, the index is 3. Okay, and the basically it is 0. Okay, then it will move on next. Okay, that is 11. Okay, if it has taken the 11, then simply index would be 2. Okay, and 11 plus 5 16. Okay, the total value is 16. So it is extending the target, then it can't move forward. Okay, if it is not taken, then simply 2, then it will simply go on till the number would be same. Okay, and if it's taken here, then it will simply 3 2. Okay, so number index would be 2 and 5, and here you can simply say 2 and 0. Okay, if it is not taken. Okay, then simply, okay, one thing I have, because it was 11 for 11 not 5. Okay, so simply we can say it should be here 11 plus 5. Sorry, no, here should be 5 and here should be 11. Okay, so simply here we have found the target, then it will simply return true. Okay, simply it will return true. But if we move forward, then it can simply go on till further, but it will simply return true whenever we found the target. Okay, so simply here we have found the target. So that's why it will have two base cases. If I just write the base cases, okay, how will this look like? Okay, so if target becomes equals to 0, okay, so we will simply return true. Basically we have found the target. Okay, and one more case will be if index also becomes 0. Okay, from last to first. Okay, then we will say return if basically if last elements is equals to the target or not. Okay, if it is equal, then we will return true. If it's not, then we will simply return false. Okay. Okay, so this is how the function will become. If I basically use this, every time the target will be small. Okay, so simply like if I just say one thing I have told you, let's just remove this and tell again. Okay, so okay, so how basically we will do it. So first we will say, okay, function, and the index is last, that is 3, and the target is still remaining 11. So basically this is how the basically approach will work. Okay, if we have chosen 5, okay, if we have chosen 5, the target would be simply reduced by, if we subtract this, okay, that is 6. Okay, So simply let's just write 6. Okay, and if we have not chosen, the target would be same. Okay, and then we will simply move forward. Whenever the target becomes 0, it will simply return true. Okay, and it will be have simply two choices, that is bool, that is take, that will simply like skipping the element. Okay, basically no, this is like not take. Okay, I have written this not take. This is simply like skipping the element. Okay, index minus 1. Okay, simply it will skip this and the target would be same. Okay, and then the next thing would be take. That will simply we will say false. We can't directly say. Okay, like if one thing that will be, if the target, okay, the target is greater than equals to the this array of index. Okay, because if it is not greater, then simply we can't say. Okay, because we have to subtract the target. Okay, then simply we will say take equals to f index minus 1, and then we will simply target, we will string the target by array index. Okay, we will subtract this with the, okay, then simply this is the, and then at last we will return take or not take. Okay, okay, so this is the basically recursive solution that will simply give the result. Okay, this will, okay, so this is the basically top bottom of approach, like from last to first. Okay, in this first we have discussed the like I have totally basically tell that approach that how we will going to work, but basically we are starting from the target, and then we will simply subtract one by one, and then we will get the answer. Okay, then we can simply memorize it, because it will give the time complexity would be 2 to the power n. Okay, we will simply memorize it. How basically we will memorize it? We will memorize it with the dp array. Okay, so simply what we are going to do, we are going to simply add the dp array. Okay, so first dp array will be added here. Let's just move it. We will take a dp array. Okay, and then you know that in dp array we will, what we'll do, if dp, that is simply index and target. Okay, if it is not equals to -1, okay, you know that -1, then simply we will return this dp index. You basically, you know that by we memorize it for basically the repeating in recursion. You know that it basically repeats the same calls again and again. So to reduce this, we use dp array basically to reduce the calls. Okay, so that the time complexity from 2 to n, it reduces. Okay, so simply if we will do this, and the second thing will be at last we will return here. Okay, so this is like dp and target equals to, okay, so simply this is how the memorization will work. Okay, so simply next we will move on the dp solution, that is dynamic solution, or you can say iterative solution. This will the simply this can also be run. Okay, this will also give solution. For dp solution, basically you know that let's just how we'll see. Basically you know that we will use loop. Okay, for first, that with the loop will be for index. Okay, that will simply contain I small less than n. Okay, that will go on the I plus plus. Okay, simply let's just take it. Okay, so simply then this dp 0, then we will write the base cases from here. You can see the base cases are if index equal to if the target equal to 0, we will return true. Okay, so if the target, that is simply we will write the base case, that is simply, okay, it's one thing that dpi. Okay, the target part should be 0. Okay, target is second. Okay, so simply if this is 0, then we will simply return true. Okay, then the second base case is if dp, that is 0, index is 0, and target could be and target its array of 0. Okay, then simply we will return true. Okay, then for next this will simply the base cases. Okay, then we will simply start from index, that is the main loop. Okay, we will start from 1. Okay, then index less than till n. Okay, then simply I plus plus. Okay, then simply okay, the same these are the basically the same cases. Okay, that we use the dp. Okay, same like basically just use the second loop, that is for the target. Okay, equals to 1, target less than equals to k, and then target plus plus. Okay, simply we can say this is the, and then the same thing that we will copy it. Okay, okay, so we have copied. Okay, okay, so in this what we are going to do, with just minor changes. For in place of this faf we are just using dp. Okay, okay, so just minor changes. Okay, and in this also. Okay, so it's like same. Okay, and here also in return replacing. Okay, so we will replace this, and it is same. Okay, then at last here we will return dp of n minus 1. This is like top down, so simply it will, the answer will contain at last. Okay, so this is the dp solution. Okay, so these are the solution total. I have told you all 3 solution. Okay, we will see the solution in Leetcode also. Okay, so that's,
here's the code for the, that's the question. Okay, so this is the memorization code. Okay, you can see, let's just use this code. Okay, you just comment out. Okay, so let's just open this. Okay. So if I just run it, okay, so this will work. Okay, okay, so you can see what we have done. You can see simply this the base case, that is if target equal to 0, return true. Okay, this, and you can see it's simply the dp. Okay, not take and take. Okay, you can see, and in this we have first calculate the sum. If sum +2, that is simply odd, then simply we will return false. If it is not odd, then simply we will get this. And this, let's just use this solution, that is the simply dp solution. Okay, iterative, you can say. So simply this is the iterative solution. Tabulation, you can say that also. Simply this is like we have used this, that is for calculating the sum. Okay, k is equal to is sum by 2, that's the target. Okay, simply we have used this, there are 2 loops, and you can see this. Okay, so simply if I just run it, so you can see it's run it. Okay, so the time complexity is big of n into basically k, that's the time complexity. Okay.